Morning. We're now going to cover the last segment of the surds section of Year 10. And the last section is called Rationalising the Denominator. Now, a surd by definition is an irrational number. Let me show you on the calculator what that means. So, the first example, we've got root 5. So if I type in root 5 into my calculator, I have this horrible looking number here, 2.236067977. Now, a surd by definition is an irrational number. That means that I can't express this number as a fraction of two integers. All right, so a surd is irrational by definition. When we're rationalizing the denominator, what that means is we want to create an equivalent fraction to 3 over root 5 where the denominator is not a surd. Now, let's just quick reminder of equivalent fractions. You should all know what that is, but I'll just do a quick summary just so that we're all happy. I'll get my black pen out. If we take an example like 1 over 4, you're very used to the fact that if I multiply 1 over 4, the numerator and denominator by the same number, let's say we multiply the numerator and denominator by 2, we will get 2 over 8. And if I multiply this 2 over 8 numerator and denominator by something like 3, I would get 6 over 24. Now, because I've multiplied the numerator and denominator by the same number, I create three fractions that are all equivalent. So 1 over 4 is equal to 2 over 8 is equal to 6 over 24, which is equal to 0.25 as a decimal. We are using this theory and applying it to questions that involve surds. So my task here is to create an equivalent fraction for 3 over root 5 where the denominator is not an irrational number, i.e. a surd. To do this, all we have to do is apply our index laws. We know that root 5 is 5 to the half. Now, if we multiply by the same root, we would get 5 to the half times 5 to the half, which is 5 to the 1, or 5, which is a rational number. So when we're rationalizing fractions where the denominator is a surd, what we want to do is create an equivalent fraction such that we multiply the denominator by the same surd to create a whole number or an integer. So the process for these simple examples are quite easy. We are going to multiply the numerator and denominator of 3 over root 5 by root 5. Now, multiplying 3 by root 5 gives us 3 root 5. And multiplying root 5 by root 5 gives us 5. We have now got a situation where we have a fraction where the denominator is a rational number, 5, and the numerator is 3 root 5. Now, this is fine. This is completely correct and finished. It doesn't matter if the numerator has a surd on it because we are rationalizing the denominator, which is what we have done here. Applying the same logic to the next example, we are going to have the fraction 10 over root 7, and we want the denominator to be a rational number. So what we're going to do is multiply the numerator and denominator by the surd that's on the denominator. So we're going to multiply the numerator by root 7 and the denominator by root 7. Actioning that, 10 multiplied by root 7 is 10 root 7. And root 7 multiplied by root 7, using our index laws, is 7 to the half times 7 to the half, which is just 7. Now we have a denominator where the number on the denominator is rational and the numerator is 10 root 7, and that's fine because we are only interested in rationalizing the denominator. And now if you look, because we've multiplied in both examples the numerator and denominator by the same surd, we have created an equivalent fraction. We haven't changed the value of 10 over root 7 or of 3 over root 5 because we have multiplied by the same number on the numerator and denominator. Those are the simplest examples of rationalizing the denominator. Let's look at a slightly more complex version. So these sets of examples have the surd on the denominator multiplied by something else. The temptation that students have is to multiply the numerator and denominator by exactly what's on the denominator. So in this example, it would be multiplied by 5 root 5 and multiply it by 5 root 5. Now this will create an equivalent fraction which will remove the surd. However, it's not the simplest fraction you can create, so this is not the strategy. The strategy is purely to multiply the numerator and denominator by the surd that's on the denominator. So instead, we want to multiply just simply by root 5, because that will also remove the surd and give us an equivalent fraction in the same vein. So let's multiply the numerator by root 5 and the denominator by root 5. 2 multiplied by root 5 is simply 2 root 5. And 5 root 5 multiplied by root 5, the root 5's combine to create 5, and you're left with 5 times 5, which is simplifies to 2 root 5 over 25. And now we've got a denominator that is a rational number, and therefore I have completed the task that I've been given. Another example, now again, we're not multiplying the numerator and denominator by 2 root 6. We only have to multiply the numerator and denominator by the surd that's on the denominator, so that's going to be root 6. 3 multiplied by root 6 is 3 root 6. And 2 root 6 multiplied by root 6 is going to be 2 multiplied by 6 to the half times 6 to the half is 6 to the power of 1, which is just 6. And that simplifies to 3 root 6 over 12. Now, when you get to the end of these questions, you can simplify if possible, but in both of these situations, it's not possible. 2 root 5 over 25 can't be simplified any further, and 3 root 6 over 12. Well, actually, this one can be. This can simplify down to root 6 over 4. Because the 3 and the 12 can go down to 1/4. That could be simplified. So it would be 1 root 6 over 4. We don't write the 1, so it simplifies to root 6 over 4. So my mistake, this one actually can be simplified, and that would be your final answer. Those are the basic examples of rationalizing the denominator. To do more complicated ones, we're firstly going to look at multiplying out double brackets for the more complex versions of these questions. Now, let's take this example and quickly show you on the sheet what students tend to do, and which I really don't like, is a lot of students, based on what you were taught before, use the FOIL method, which is first outside, inside, and then last. I really don't like this method. The reason why, it's not because it doesn't work, it does, and I've actually done my loops the wrong way around, but you still understand what I'm getting at. The reason why I do not like FOIL is because it only works for double brackets. If you have triple brackets, FOIL does not work for this example. So what I prefer to do is use the grid method. Now, students don't like this, but it always works, and it's way more rigorous because it works for every single example. It works for expanding brackets like this, it works for triple brackets, and it works for, your double brackets. The grid method works for all 3 of these types of examples, whereas FOIL only works for double brackets. So I'm going to be doing the examples on the sheet using the grid method. I strongly encourage you guys to get in the habit of doing that as well, because it is way more versatile and works for the full range of examples you can come up against when we're multiplying out brackets. So we get our grid method ready. I put my multiplication sign in the corner. And then for the first bracket, that will go in my rows. So the X term will go here and the +1 will go there. For the second bracket, they will go in the columns. It doesn't really matter which way around you do it, but I'm just doing it like this. So the X term will be here and the +2 will be in the second column. And now all we have to do is multiply out each row and column to create 4 terms. So X times X is X squared. X times +2 is +2X. +1 times X is 1X, just written as X. And +1 multiplied by +2 is +2. Now all we have to do to finish is collect our like terms. So we've got X squared, which is on its own. There's no other X squared terms. The 1X plus 2X creates 3X, and then the +2 is on its own. So that is our finished article there. Another example, slightly more complicated, but exactly the same method being employed. We're going to use our grid method again. Our multiplication signs in the corner. My first bracket will be in the rows, so the 3x will go here, and the +1 will go here. The 4x will go in the first column, and the -2 will go in the second column. And we're just going to multiply out to create our 4 terms. 3x times 4x is 12x squared. 3x times -2 is -6x. +1 multiplied by 4x is +4x. And +1 multiplied by -2 is -2. And then we collect our like terms. The x squared is on its own, so it'll be 12x squared. -6x plus 4x is -2x, and then we're left with the constant at the end, which is just -2. And that is our finished article. Now you'll notice that each time we multiply out double brackets, we're normally left with 3 terms. 1, 2, 3, 1, 2, 3. We're going to look at an example now where you only get 2 terms, and this will be really important for rationalizing surd questions that will come up a little bit later. So now what they're called are conjugates, this example. So conjugate means we have 2 brackets where the terms look exactly the same, an x term and a 1 term. However, the only difference is the sign for both brackets is different. So you got x plus 1 and x minus 1. So x minus 1 is the conjugate for x plus 1, and x plus 1 is the conjugate for x minus 1. So just to recap, conjugate just means that the terms look exactly the same, x and 1. However, the sign is different in the 2 brackets. So you got x plus 1 and x minus 1. That is what a conjugate is. Each bracket is the conjugate of the other. Let's multiply this out using grid method to see what happens here. So multiplication in the corner, we got our x term in the first bracket in the first row, and the constant in the second row. And similarly, we got the x term in the first column for the second bracket, and the constant for the second bracket in the second column. X times x is x squared. X multiplied by -1 is -x. +1 multiplied by x is +x, and +1 multiplied by -1 is -1. Let's collect these like terms. We've got our x squared term is solitary, so it stays the same. Then we have +x and -x. Now these cancel each other out. +x minus x is 0. And then we have the -1 left. So simplifying this, we have x squared minus 1. So conjugate brackets only give you 2 terms when we've got 2 double brackets, right? That is extremely important to remember when we move on to rationalizing 2 terms that involve surds. All right, so conjugate brackets only give us 2 terms, whereas all other types of double brackets give us 3. 1, 2, 3, and 1, 2, 3. Let's look at examples that involve surds. Now we're just going to quickly do a couple of examples of multiplying out brackets, double brackets that have surds in them. So let's look at this example. 1 plus root 2 all squared. This can be written as 1 plus root 2, 1 plus root 2. So let's use our grid method. The 1 goes in the first row, the root 2 goes, plus root 2 goes in the second row. The 1 in the second bracket goes in the first column, and the root 2 second bracket goes in the second column. 1 times 1 is 1. 1 times root 2 is root 2. Root 2 times 1 is root 2, and root 2 times root 2 is 2. Now, let's collect these like terms. So 1 plus 2 is 3, and root 2 plus root 2 is 2 root 2. That would be our final answer there. Now, the problem with multiplying out double brackets, this time we do only get 2 terms. So it's slightly different when there's no variables present. These are all numbers, so when there's no variables present, you only get 2 terms as well. However, there is a surd still present in this final answer. All right, and remember, when we are rationalizing the denominator, we don't want to see any surds present. So let's look at an example that involves a conjugate. Here we've got 1 plus root 2 and 1 minus root 2. Now this is the second bracket is the conjugate of the first bracket, and similarly the first bracket is the second bracket. The first bracket is the conjugate of the second bracket. Where we have two terms that look the same. The only difference is the sign in one bracket is different from the sign in the other. Let's multiply these out. So grid method again. I appreciate you might be well equipped to carry out grid methods by yourself, but let's just humor me for a moment. So you've got 1 and root 2, and then you've got positive 1 in the second bracket and negative root 2. Now here, 1 times 1 is 1. 1 times negative root 2 is negative root 2. Positive root 2 times 1 is positive root 2. And positive root 2 minus root 2 is negative 2. Combining these like terms, they have 1 plus root 2 minus root 2 minus 2. Now the roots cancel, and we're left with 1 minus 2, which is negative 1. And we are left with a rational number when we use a conjugate, which is exactly what we want when we're rationalizing the denominator. So what we've learned from this process is that when we multiply double brackets that involve a conjugate, you're left with a rational number. When you multiply out double brackets with surds that don't have a conjugate, you're still left with a surd whenever you simplify at the end. So this is the method we are going to use when we're rationalizing a denominator with more than one term that includes a surd. Let's look at a few examples. So we've got 6 over 4 plus root 3. This denominator has two terms, one of which is a surd. So we're going to have to multiply by a bracket on the numerator and denominator. And we will want to use the conjugate method because it creates a rational number at the end. So 4 plus root 3, the conjugate for 4 plus root 3 is 4 minus root 3. So we're going to multiply the numerator and denominator by 4 minus root 3. Now, this will give us 6 bracket 4 minus root 3 on the numerator. And on the denominator, we will have 4 plus root 3 bracket 4 minus root 3. So we'll have to do a few grid methods here, but it will be worth it in the end. So let's do the expanding the bracket on the numerator first, which is a little bit easier. So you got 6 on the row, 4 and minus root 3. 6 times 4 is 24, and 6 multiplied by negative root 3 is negative 6 root 3. So our final answer for that one is 24 minus 6 root 3. For the denominator, hopefully I've given myself enough room to do this. We have 4, positive root 3, and then 4, that's positive 4, negative root 3. 4 times 4 is 16. 4 times negative root 3 is negative 4 root 3. Positive root 3 multiplied by positive 4 is 4 root 3. That's positive. And positive root 3 multiplied by negative root 3 is negative 3. So now we are going to tidy that up. We've got 16 minus 4 root 3 plus 4 root 3 minus 3. Now the surd terms cancel to create 0, and we're left with 16 minus 3, which is 13. So on the numerator, we have 24 minus 6 root 3 over 13. That is our final answer. We cannot simplify that any further. The only way that we could technically simplify it is if we take out a 6 on the numerator. So you could simplify it as far as 6 bracket 4 minus root 3, which is just factorizing the numerator over 13. That's the only way, but normally that should be fine. I'll give you the marks. Let's go for the final example. So root 5 plus 5. Now, because we've got two terms, then one includes a third, we're going to multiply it by the conjugate, which is going to be root 5 minus 5 on the denominator, multiplied by root 5 minus 5 on the numerator. So multiplying that out, I'm going to do this slightly quicker this time because we've got a previous example to show for it. So this would simplify to 2 root 5 minus 10 over, let's do the double bracket for the numerator. So I've got root 5 and positive 5, and then root 5 and negative 5. Root 5 times root 5 is just 5. Root 5 multiplied by negative 5 is negative 5 root 5. Positive 5 multiplied by root 5 is 5 root 5. And 5 multiplied by negative 5 is negative 25. Collecting all of these, we have 5 minus 5 root 5 plus 5 root 5 minus 25. The root terms cancel, and we're left with 5 minus 25, which is negative 20. So we have negative 20 on the denominator. And now we can factorize a 2 out from the numerator, which would give us 2 root 5 minus 5 over 20, and we'll just put the negative sign in there at the beside the fraction because it's the same as the row above. So that should be our final answer there.